In this video, we're going to do a deep dive on infrastructure patterns for agentic applications. So let me give you a quick outline of what we're going to go over in this video. First, we're going to be discussing the concepts of agentic applications, the architecture, the patterns, and we'll go over 3 different implementations and discuss what the pros and cons are. After that, we'll look at some code snippet examples of how these architectures start to get put into practice. And then we'll go over to our associated GitHub repo, which is open source that you can clone. And we're going to deploy this live on this video so you can see how to deploy these 3 different agent patterns on Render. I also want to mention that we have a guided tutorial on render.com/tutorials that goes in detail about what I'll be discussing in this video, as well as a blog post to go along as well. All right, now let's go ahead and jump in and discuss some patterns in agentic software. So first off, agents can be very long running. You can have tasks that are running for hours or even days long. For example, using Codex or Claude Code, it might be working for many hours. It's not just a simple HTTP request where you make the request, wait for the response, and then perform an action. Next, the agentic payloads can be really dynamic. Maybe an agent does 1 API call, and then the next time the same question, it does 10. Maybe the payload is different. Maybe it uses different APIs. So they're not all deterministic, and we need a really flexible execution environment. Next, we need our agent to be stateful because it needs to manage its context window. It needs to manage its memory from past messages, and it needs to be able to store all of the progress that we make on the tasks it's working on. So based on these agentic patterns, there are a few requirements that we can infer we want in our infrastructure. First, we want to be able to decouple the request from the run in case they are far separate from each other in time. Secondly, we need to make sure that we're controlling any side effects that can happen from the really dynamic execution of the agents. For example, if the agent is creating files or changing the code base, we want to make sure it remains reliable as we continue to run the agent. And also, we want to make sure that if any task fails along the way, we have a way to remedy that. And third, we need to make sure that we have a good system for managing state throughout the whole application to record our not only memory, but also our progress. Okay, so let's talk about one architecture implementation for production agents. When using a queue and background worker architecture, we could have a system like this where we have an API that sends a request, the request gets queued, and then the request eventually gets sent to our agent worker for execution, and then we can store our results from this into a Postgres database. So this solves some of the requirements we just talked about, but not all of them perfectly, so let's dive a little bit into the pros and cons here. The queue and background worker architecture, it does solve the run and request decoupling, the lifetime problem, because we can queue up tasks even if it's running for a very long time. We don't have a perfect execution environment yet because in this architecture here, we don't have a task level granularity. So if the agent is working on 10 tasks, it's all in this black box. And we also want to consider that we need to have reliability in future runs and manage all the side effects. So now let's go into the next architecture, which is workflows. So workflows are going to give us a much better execution environment. They allow us to manage the continual run and reliability of these agents, and they allow us to compensate for any side effects that an agent might create. Next, we'll go into another factor of workflows, which is a pattern of fanning out and fanning in. So you may know this as parallel agents. If you've worked with coding harnesses like Claude Code, sometimes you can ask the orchestrating agent to spin up a team of sub-agents, and that's also known as fanning out. So when we fan out, this can be very useful for completing particularly similar tasks in parallel. And when you fan out, the other element of that is you have to fan back in. So there are some considerations of how do you consolidate parallel agents back into the record that you want to keep. For example, what do you do if one of these branches fails? Do we want to redo that branch? Do we want to move forward anyways? Do we want to not move forward and we require all of them to succeed? And if we do want to move forward, how do we synthesize the partial results? Do we record that one of them failed? What if the tasks in these parallel agents take 10 minutes, 1 hour, 3 hours, and they're all different times? We need to reconcile that. And we also want to consider that parallel agents and fanning out is best when the tasks are not interrelated with each other, so they don't conflict with each other. So now let's talk about the third architecture consideration here, which is combining the two. And this is a great solution for at scale in production because it offers the best of both systems. So using a workflow and a queue together is the best of both worlds because we have a great orchestration and execution environment, and we also have the queue that can allow us to distribute the execution to the correct environment. Now that we've discussed a lot of the concepts and patterns in agentic applications, let's take a look at the actual services we're about to deploy onto Render, and we'll also look at some code snippet examples of how to implement the patterns we've talked about. So these are the actual services we're about to deploy. We're going to use a render blueprint, which will allow us to deploy them all at once and make it nice and easy, our infrastructure as code solution. So we'll deploy a web service for our API, a render workflow for our execution environment. We'll have a KV store for our agent memory, and finally a Postgres for our record. We'll also get the baked-in render observability so we can see what's going on with our application. So taking a look at some examples of how the patterns we've discussed are implemented in code. First, we have the trap that we're avoiding with this pattern. So in this example, we have an HTTP request that is waiting for the result of the request before continuing on. And that's what we want to avoid. And we have been able to decouple the request from the run in our workflow pattern. Our next example, we have an agent loop, and you can see that the agent is loading from memory, running tools, and then adding to its memory. So our KV store will allow for that. In this example, we are demonstrating a queue where we can create an agent run and then queue that run for execution. In this example, we have an agent that is executing and then saving the results into our Postgres. So here we can take that unique run ID and make sure we run any compensations. So for example, if a new customer was created and then all their other tasks failed and we need to undo that customer creation, we can use the unique run ID to compensate to make sure that side effect doesn't get in our way. And finally, we have another example where we can bring all these steps together. So we can create a run, we can plan, we can execute tool functions, record our results into Postgres, and then synthesize everything together. All right, so now that we've gone through the examples, we've talked about the concepts, let's go ahead and deploy. So I'm going to go over to render.com/tutorials, click into this agent 3 ways on render, and we're going to skip down to the workflow implementation. I'll go over to my render dashboard, and we're going to make a new blueprint. You could also do this through the CLI or MCP. I'm going to grab this repo right here, and we will name this workflow agent example. We'll grab the blueprint path URL here and paste that in. And then let me grab a test API key here. The GitHub token will be automatically generated, and the workflow slug we're going to fill in after we deploy our workflow. Our blueprint will deploy everything but the workflow. So let's go ahead and deploy that. And now we'll go back to our tutorial here while that's deploying and get ready to deploy the workflow. And now let's go ahead and create our workflow service. This is the command that you'll run in the CLI and just replace your repo branch and your database URL, which we are going to get shortly. And then you can also do this through the dashboard if you prefer, rather than the CLI. So I'm going to go over to our new project, Workflow Agents, and we have our DB here. We'll see if I can grab the connection ID. All right, so this is deploying. As soon as this is ready, we'll grab the connection ID here and then use that to deploy the workflow. All right, that's now available. We'll grab our ID here. I'm going to paste that into the command that I've already updated with my information. Grab this command. Okay, let's go over to our repo and we'll run this command to create the workflow. There we go. And then we can run render workflows list. And there is our workflow agent right there. Now we need to set up the workflow slug. So we'll go into our dashboard and we'll go to our new deployed workflow, grab the slug here, go to our project, workflow agents. And the reason this gateway deployed is we need this slug right here. So we'll go into our environment, add a new environment variable, paste that in, and redeploy. Okay, the build is successful, so let's go ahead and visit the gateway. And then we have our web service here, which is connected to our workflow. And for this agent, we can perform a code review. That's what the agent is doing in this example. So we'll go ahead and take a PR example here and click review, and that is going to be running our workflow. We can go back into the dashboard here, and if I go over to all projects and then into our workflow, we can see the run code review just ran right here. We can click into it and see some observability. So we have our workflow agent running in production. The only other thing I want to mention is if you prefer to use MCP or you want to get set up with the CLI, you can go to render.com/agents, and we have different documentation here on the workflow CLI and other details. So thank you so much for watching this video. I hope this was helpful. Please be sure to like and subscribe. Stay tuned, and I'll see you in the next one.